Guys, continuing with our earlier discussion, before we even dive in, let me clarify a couple of important things. Um, what's the difference between distance vector protocols and link state protocols, right? AGRP RIP are generally a distance vector, whereas OSPF, which we are looking into right now, is a link state protocol. So how are they different? Look at this example. So you have three routers, R1, R2, R3. Let's say the A is basically the loop back behind R1, right? Now in case of EIGRP or a RIP protocol, how does this work? R1 advertises the route A to R2, R2 will advertise A to R3, but will not tell R3 where he got the route from, right? So R3 will just know that in order to reach your A, it needs to go through R2, but it doesn't actually know behind which router you have this route A, right? That is, it doesn't have the whole visibility of the whole network, right? The visibility is very limited to the next hop. It just knows that in order to reach A, it has to go to R2. That's it. That's the only information. Now consider the similar scenario in OSPF, right? So the interesting thing is OSPF doesn't exchange routes, it exchanges link state, right? So in OSPF, R1 advertises that it is connected to A, right? And that information goes to R2. Now when R2 receives that information, right, it's going to forward as is whatever information it got, it's going to forward it to R3, right? So as a result of that, R3 will now know that the route A is actually behind R1, right? So when R2 advertises that information, it will also advertise that it is connected to two other routes, so that information also will be given to R3. So R3 now will be in a better position, or will have a complete view of the topology, and it can kind of like reconstruct the topology on its own, right? Because it knows that A is connected to R1, it also knows that R2 is connected to these two links. So internally it will be or OSPF is intelligent enough to kind of like create its own topologies. So that's the reason why we say link state protocols, basically they have a complete view of the topology of the network, whereas your distance vector routing protocols just they just have visibility only to the next hop, right? Great. So moving on. So now in this particular section, what I've done is we are still using the same topology, but I have just added another area to the last section, right? So yeah, so we'll have to do a bit of adjustments to the existing configurations. We have already configured all of this in the earlier video, so we'll just go and edit it on my R7 and R8 because we have to add another area, right? So if you go to my router, my R7 is here. Just pull this a bit this side, right? So if you look, I currently have show run section router, right? R7, and my R8 also is going to be something similar. Clear the screen, enable, and that's my R8, right? So what do? So we have to add one more area, right? So yeah, let me just which are those routes. So we are talking about the 192.178.0. so that particular section that has to be in area 10, right? So let me go inside configure router EIGRP, was it sorry, router, I mean, my bad, OSPF 1, and let me remove this particular, we do a no here, and let me add it back again, but with area being 10 now, right? I'm adding a new area here, right? And probably let me also take this particular loop back and put it in 10. So let me just remove this. Okay. Let me remove this, and right, this is going to be area 10. So you have done the work on R7. We will have to do it on R8 as well, right? Let's go back to R8, configure, let's go to router OSPF 1, right? So R8 yeah, So both of these we have to change, right? So let's remove this, and let's remove this as well, right? We will go and put this in area 10. Good. And this one as well in area 10. Okay, looks good. Let's look on my this is my topology. So this is R7, R8, right? So let's check this. Let's check on R7. Do I have all the routes now? Show IP route. Yeah, 1 2 3 4 5 6 7 looks good. 8, all of that is good, right? Great. So now let's talk about your LSAs, link state advertisements. What we'll try to do is we'll try to create our own link state database, and then we'll try to verify if that matches with the actual from the topology, right? So let's start with building it ourselves. Let me go down to my text editor here. Let's say this is the link state database. Now the first router is the router 1, right? So they are identified by their router ID. On router 1, what do you think are the advertised networks? We have one loopback here behind it, and you have the 192.100 network, right? So let me just call it as 1. I'm referring 1 to the loopback address. It will have a cost of 1 as well because it's a loopback, whereas the .100 network I'm just going to represent as 100, and it is going to have a cost of 10 because it's a Ethernet interface, right? So that's going to be for router 1. Similarly, if I go for router 2, it's going to be for dot 2. The loopback is 2, right? And the network which is advertised is, what are the networks which are advertised by router 2? We have the 100 network as well as the 25 network, right? So the 25 network, but it will have a different cost because it's a serial interface, so it's going to be 64, right? So that's, let me just put a tab here. I think this is better, right? Great. So that's R2. Let's also see R3. What will happen to R3? If you see R3, right? So R3 would be we are going to have a loopback 3, right? It is also going to advertise the 100 network, right? And there is no serial interface on R3, which is R3 over here, right? So we're going to have the 100 network as well as the 200 network. So you'll have 200 with the cost of 10 again. Okay, that's your R3. Similarly, we have to do the same exercise for R4. Let's do for R4. Let's go down here, right? Just put this aside, 4. And if you look at 4, this is the router 4, right? And it is going to have a loopback of 4.0, which we have already defined earlier. So it's going to be 4. It is going to advertise the 4. Then it's also going to advertise, there won't be 100 network, obviously. There will be the 200 network, right? And the 45 network, right? So you need to have the 45. Let's put the 45 with the serial maybe 64, right? Good. So that's R4. 5, 6, 7. Let's do the rest of them. So let's go to the 5th one. That's router 5, right? So if you see the router 5, the ID is 5. The loopback is going to be 5. What else? This is 5. So it has 25 and 45, and both are serial interfaces, right? So there is no 200. You could remove this. So there's 45, and the other one is 25, right? So this is going to be the advertised networks for R5. R6, let's do R6 as well. Okay. R6 obviously it's going to have a loopback. And what else? R6 has the .200 network and .67 network, right? So none of these ones. So we have 200 and 67, both with the cost of 10 because it's a Ethernet interface, right? So there you go. Next is your R7, right? You're gonna have on R7 you're gonna have just 2 networks, right? So you're gonna have 7, and you have 67 as well as the 78, right? So let's put that 67 is there. Let's put 78, right? Great. The last one is your R8. Let's do the R8 as well. So actually R7, so we are talking only about area 0, aren't we? So let's remove R7. Let me do one thing. let me just remove this. This is not needed. So we are just talking about area 0. We are just trying to recreate the linked state database for which one? For my area 0, right? And if you look at area 0, you have R7 and the 67 network. You don't have the 78, so I can remove this as well, right? So there you go. So this is basically my linked state database for my area 0, right? Now we need to understand the various types of LSAs. So we will understand that as we go in. So if you look at, let's take R7 itself, right? This is my R7 router. I go in, clear the screen. So how do I, so these whatever I wrote down here, these are basically the routing advertisements, right? And that's basically your type 1 LSA, right? So what is type 1 LSA? Basically where the routers are advertising their networks. That is your type 1 LSA. How do you see the type 1 LSA on a router? You do show IP OSPF, right, database, and then you say router, because they are router advertisements, aren't they? So when you hit the enter, you basically see that this is the routing advertisements for area 0. You will have the other section where it is for area 10, but we are just interested in area 0 for now. And all the routers in area 0 will have the same database, right? That's the whole idea of OSPF, isn't it? And it's going to be well in line with what we have defined here, right? So you can see here, for example, this is the 01 router, right? Very much same as here. It is advertising two networks. One is the 1 network and the other one is your 100 network, dot 100 network, which is the transit network, right? Dot 100 network here, right? So now if you go to my R2, right, this is my R2, and it is advertising. If you see in R2 we have 3 networks, right? You have the 2.0, you have the 25 network, right, and you also have the 100 network, right? I will tell you what this is in the next section, but for now you can see that whatever we have defined, right, earlier in my in the linked state database is very much in line with the type 1 LSAs. So this is your type 1 LSA. So all the routers, if you have time, if you go through all the routers, right, all of them are going to actually show you the same database, right? So that's your type 1, as simple as that. Okay, I hit the enter here. Great. So that's type 1. But what is type 2? Okay, what is type 2? So though we have type 1 LSA where the routes are advertised, we need someone to validate them, right? So that the designated router for the segment validates the router IDs present in the segment, right? So which means, so if I have to write down my type 2 LSAs, let me just go down and let me write down the type 2 LSAs, and then again we will go and verify them from the show outputs, right? So what I mean by the designated router validating, right? So type 2 LSA for segment. So we know that there is only one designated router for every segment. So let's talk about the 100 segment, 200 segment, and the 67 segment, right? So you see here we have the 100 segment, 200 segment, and the 67. So we have 3 segments in area 0, right? And we are talking about type 2 now. Okay, so when I say the designated router is validating, it basically tells that the designated router is the one who is going to generate this type 2 LSA, and it's going to tell that in the segment 100 we have 3 routers, right? It's going to say, okay, we have router 1, router 2, and router 3. So that's basically the information which is obtained from type 2 LSA. Similarly, in the 200 segment we have router 3, we have router 4, right? We have the 4 and we have the 6 one, right? These are the router IDs what I'm typing down here. Similarly, in 6 and 7 we have 6 and you have the 7, right? So from here you know that you have router 1, 2, 3 in 100 segment, you have 3, 4, 6 in 200, and in 67 segment we have 6 and 7, right? Now this is basically your type 2 LSA, right? So it is also called as a network LSA. How do you see it? If I have to go to R7, I can do show IP OSPF database. I do a network command, right? So when you do that, it basically is telling you that, look, if you look here, this is for segment, which segment is this? Let me just hit the enter, type 0. Yeah, so for area 0, right, here you have for area 0, where is the 100? Let me show you the first one here. So that's for area 0, and this is the advertising router, because R2 apparently is the designated router for that segment, right? And it is basically advertising that we have 2, 1, 2 and 3, right, which is in line with what I have put here for segment 100. For segment 200, where is segment 200? Here, segment 200. For segment 200 we have 3, 4 and 6, right? Similarly for segment 67 you have 6 and 7. So that's basically the idea behind the type 2 LSAs, right? So type 2 or the network LSAs are basically advertised by the designated router, and they are just there to validate where the designated routers are going to call out the routers present in their jurisdiction or the segments. Okay, so now there could be a very interesting question. We know that type 2 LSAs can only be sent by the designated routers. So how do we validate point-to-point networks, because we don't have designated routers in point-to-point networks, do we? Right, so if you look at these two networks, we don't have any designated routers. So how do we validate, right? So in point-to-point network, right, where a router R2 advertises, say, the 25 network, right, it will also advertise its neighbor, which is R5 in this case, as another type 1. It's a complementary to the type 1. So the validation of the validation in case of a point-to-point network happens in the type 1 LSA itself, right? So it is going to be something like this. So if it's a point-to-point network, this is how the type 1 LSA looks, right? For I mean, we did not account here, probably we can write it down here itself instead of creating it again. So this was the type 1 LSAs, right, which we defined earlier. So if you go back to the point-to-point network, which is R2, so for R2 what is going to happen is that along with advertising the 25 network, right, this 25 network, it will also tell that 0.0.0.5 is actually my neighbor, right? This is what it is going to do. So this validation happens in the type 1 itself, for which point-to-point networks, right? So this happens for R2. It will also happen for R5, right? For R5, let me go down to R5. So it is going to happen for R5. For 45 network, it's going to say 0.0.2 is my neighbor, and it is also going to do the same thing for the other one, which is if you look at here, the 45 network is connected to 4 and the 25 network is connected to 2. My bad, right? This is 4 and the 25 network is connected to 2, right? So let me just put this as 2. There you go. So this is basically the validation. There is one more network, which is my R4, right? The R4, where is my R4? Here. The 45 network, right? It's going to also say that along with the 45 network, 5 is my neighbor to it, right? So this validation happens, right? So now we can go and check this, right? So how do we check this? Probably we can do this here itself. Let me just clear the screen again, right? So we are interested, let me do show IP OSPF. I'm just trying to obtain the type 1 LSA now, right, by hitting the router. Okay, so we are just interested in which one. We are just going to look at 0.0.2, which is for router 2, right? Here you go. We have for router 2, you can see here for router 2 we have like I said, we need to have 4 entries for router 2, right? We have this for loopback, which we have defined earlier. We also have for the Ethernet network, which is here, right, the transit network. Okay, but the next two of them, so one is the 25 network, right, which is again here, matches to this, but then you also have here something like a it's the validation LSA over here, right? You can see here, this is not advertising any network, it is just validating. It is telling that 0.0.5, which is my R5, is my neighbor, right? So it is validating here. So similarly, if you go and check, you will also find the same thing for your R4 LSA and R5 for this R5 as well, right? So validation of the point-to-point network happens in type 1 LSA. So we have now covered type 1, type 2, and we have also talked about how the validation happens in point-to-point. Now the next piece which we can look at is my type 3 LSA, right? Going back to the diagram, what is type 3? Type 3 LSA is also called as a summary LSA, right? So you see your R7 here, right? R7 is kind of like the area boundary router, right? It is at the boundary between area 0 and area 10. So R7 has the whole LSA database for area 0, right? Not just R7, all of the other routers have as well, but we are concentrating only on R7, so we are talking with respect to that. So R7 has the whole LSA database for area 0, which lists which router is advertising which networks along with the cost, everything, right? But now when R7 is talking to R8, which is actually in a different area, area 10, it is not going to send all of this information. It just sends a summary of the whole LSA database, right? So which means it is going to tell R8 that in order to reach your 100 network, 200, 25, 45, 67, you just need to go through me. That is the only information, right? Just like how in a EIGRP, the next hop kind of a view is provided, that is exactly what's going to happen here, right? It is not going to give all of the information like it would have shared with any other router within its own area. So when you're moving from one area to other, it just gives you a summary of the LSA, and it will tell you that you want to reach any of these guys, you gotta come through me, right? At the same time, it will not tell, or it won't give a complete picture as to which network is connected to which router and so on, right? So that's why it's called as the summary LSA, right? So if you go back here, let's look at the summary LSA, right? If you we can probably look at this on the R8, right? Because whatever he's propagating, it's the summary LSA is basically generated by my area boundary router, but once it is generated, it is sent to R8 as well. So let me look at R8 and let's see if we can look at the summary LSA. Right, let me clear the screen a bit, right? So now the summary LSA. So what do I do for summary LSA? You write show IP OSPF and data base and summary, right? So you see here you have the summary database. Okay, you just scroll down a minute. Yeah, so you can see here what has happened. Yeah, so this is the whole database, isn't it? So the summary LSA, let me scroll down a bit. Here you go. The summary LSA is basically telling you that in order to reach the 1 network, you have to just go to R7. In order to reach the 2 network, you have to go to R7. Reach the 3 network, go to R7. So it's basically telling you that in order to reach any of these networks which are over here, in order to reach any of these networks, you just need to go to R7, right? Which is completely different from how the LSAs are present inside the area. Inside the area, you have detailed information, right? You, like for example here, my previous one, you can see that you have detailed information. You know that each router, what it is advertising, right? And you will be able to recreate the topology. But using this information, you can't. Now R8 just knows that there are some networks of this sort, which is 25, 35, 100, 200, and in order to reach them, I just need to go to R7. That's the only information R8 has. So that's basically the summary LSA, right? It's also called as the type 3, or basically the basically the type 3 LSA, right? It's advertised always by the area border router, right? Instead of sending multiple type 1 and type 2 LSAs for a single route, it will now just send one LSA for the route, right? What I mean by that is that inside the area you had right, for you might have multiple type 1 type 2 for a particular network, right? But when this information goes out, it's going to be just one LSA per route, right? And this is basically why you call as the LSA summarization. It's not like network summarization, it is LSA summarization, right? It is done automatically by the ABR, cannot be changed, right? and these routes from the other area will appear in the routing table. Now if you look at the routing table of this guy, show IP route, right, you'll see this routes with tag called as OIA, right. So this is the inter area routes, right, and they are basically obtained because of that summary LSA. Okay, so that's basically type 1, type 2, type 3. Okay, moving on. Great. So now we will look into another interesting piece, which is the route summarization, right? Great. So in OSPF, all the routers needs to see the same routes, right? Because of this, the filtering and summarization is not done or possible within the area, right? But it is possible to do summarization of routes in OSPF when it is inter-area routes, right? The routes going from area 0 to area 10. Right, so for this exercise, to understand this concept better, what I've done is I have basically changed the IP addresses or the segments here from the earlier network. I changed this to 100, 101, 102, and 103. Okay, so slightly changed it because that will help me explain this example better. Okay, so let's continue. Let's see what we are trying to do here. So if you look here, let's probably let's mention type 1 and type 2. Okay, so let's talk about our network 192.100.0/24. okay, now my question is, if you look at this network 192.100.0, so this network, right, how many times does it appear in the linkstate database? It would appear as a type 1 LSA for R1, type 1 for R2, and type 1 for R3, right, and it would also appear as my type 2 for my designated router of this segment, whoever it is, right. It would appear as a type 2 over there as well. So if I have to write it down, it would appear R1, it would be type 1, same thing for R2 and R3, and it would also appear as the designated router. On the designated router, it would appear as my type 2, right. So this is the number of times this particular network is repeating, right, in my LSA database, right. Now same thing for the other network, which is we have to do the same exercise for the rest of the three guys, which is 100, 101, 102, and 103, right. Now 101 I would say would appear as type 1 on my R2 and R5, right, but you should also remember that it would appear as my neighbor network in my type 1 because I have explained to you earlier that because it's a P2P serial network, right, they in the type 1 LSA itself, right, another advertisement for the neighbor is actually sent. So what I mean is, if you look at let's say you're looking at 7, so let me clear the screen a bit. So if I'm looking at my show IP, OSPF, database, and router, which is my type 1, right, and if you let's say talk about R2, right, you can see here this network is appearing twice. Once it is appearing as my actual, as an advertisement of the network, and other time it is appearing as a neighbor, right, advertisement of my neighbor, right. So that's why we are going to count it twice. So it's going to come on R2 as my type 1, right, and it is also going to appear, right, on my, it's also going to appear as the neighbor for my type 5, right. So this is still type 1 though, right. The same thing is going to happen for my R5 as well. It's going to happen on R5, R5N. Okay, this is my bad, this is still type 1, everything is type 1. Okay, so that was for 101. Now if you go back and if you see what is happening with 102, 102 is going to be similar to my this case, right. It's going to appear on R4 and R5, that's the only difference. So I can just copy this and put it here. Hope you understand. This is pretty straightforward as to what we talked in the previous video as well. So R4 would appear as R4, and you also need to have it as R5, R5N, type 1. Cool. So we are just trying to figure out how many times a particular network would appear, in the linkstate database. That's what we are trying to do here, right? And the last one, 103 would appear in my R3 as type 1, R4 as my type 1, and R6 as my type 1, and also the designated router as type 2, right? Something like this, very similar to this network. Okay, Make sense? Just need to change this to 3, 4 and 6, right? That's it. Great. So we have done this. Now we have also talked about type 3, haven't we? Right? So let me put a type 3 over here. So if you're talking about type 3, so when this whole network, when R7 is sending the LSA to R8 or to a different area, right? We know that we're gonna send it as a type 3 or a summary LSA. So in that summary LSA, it is going to send, though this particular network is repeating 4 times in the LSV database, it is going to send only once, right? So when you're talking about type 3, if you come here, let me put a tab here, so it's going to go as only once, right? So that's the reason, that's why you call it as a summary LSA, right? It is summarizing, it is not sending it 4 times, it's going to send it only once. Similarly here as well, right? It's going to send it only once. The next one here, yes, here as well, same concept. Instead of sending it 4 times, it's going to send it once, and here you're going to send it once again. There you go. So this is my type 3. Now in my type 3, we basically ended up reducing, right, or summarizing all my LSAs, right? We had close to we had 16 LSAs. The 16 LSAs were summarized to just 4. That's why you call it as a type 3 LSA. Right now this is again done automatically, we don't have to do anything. Now what I actually mean by route summarization is what we are going to do now, next, right? So let's say you want to summarize, you don't want to send it as 4 routes, you want to still summarize and send it as one single route. Now that is possible, and we have done summarization many times now in the whole video series. By looking at this whole network, you can say that you can summarize these 4 networks. I'm not going to tell you how I'm doing summarization because that's already covered. So I'm just directly going to do it. 192.1, it's going to be 100.0. I'm going to summarize it using the subnet of /22. So that should do it, right? So all these 4 networks, now I can summarize it into single network. So now this is what we can do manually, right? So in this network, you had so many type 1, type 2 LSAs. Now when the ABR basically generates your type 3 summary LSA, it will automatically convert all this into just 4 networks, and these 4 networks can further be summarized into just one, something of this sort, right? Great. Now what is the command which will help us do that, right? So what is the one command? I'm not going to do this because I'll have to reconfigure a lot of IP addresses, but I'm just going to type in or explain you the command which will help us do this. So this has to be done, like I said, you have to do it on the ABR, on the area boundary router. So you already on R7, basically it's an area boundary router, you already have router OSPF. So you go inside router OSPF and you say area 0, right? And just because you're summarizing, you say range. What is the range? So it is 192.100.0, right? And the subnet mask 255 255 252, right, .0, that's nothing but /22, right? Just by doing this is the only one line of command which you have to do. Just by doing this command, what happens is that all these 4 routes, or basically 4, it would have gone as 4 LSAs, now it's going to be summarized into only one, right? So the routing table, right, of my R8, if you look at now, it's not going to have this 4 different routes, it's going to just have just one single route like this, right? So that is why this is how you can like do route summarization. And especially I'm calling this out loudly, it is inter-area routes. You can't do summarization within the area, right? You can do it only inter-area, right? And this is how you do it, right? Just to recap, on the left hand side, these were the routes, or this is how the LSA database would look like, right? Each of this network appearing so many different times in different LSAs. Now when this type 1, type 2 are going to be summarized into the summary LSA, my ABR is going to automatically convert all these LSA into just 4 of these LSAs, and from these 4, if you want to further reduce, you can summarize it using this, right? Just one line of command under your ABR, you do this under ABR, and now when the routes go from R7 to R8, or basically from area 0 to area 10, we have basically ended up summarizing, and we'll just have just one route in the routing table of my R8, right? So yeah, that's about route summarization.